Hello everyone, so today we're going to look at solving scalar nonlinear equation. So if you recall this function, x squared plus 2x minus 3. Okay, so why this is nonlinear? So a function is said to be nonlinear if the independent variable, so our independent variable is x. So now this x here occurs other than the zeroth of first power. So this is x power 2. In other words, you have more than one solution for this when fx equals to 0. Okay, so let's see, when fx equals to 0, I have x squared, just erase this thing. Okay, so when fx equals to 0, I have x squared plus 2x minus 3 equals to 0. So I have x plus 3, x minus 1 equals to 0. So I managed to find the root. The roots are minus 3 and 1. So you have the solution, the roots. There are more than one value here. There are two roots here. So this function is, we call it nonlinear, but in this case it's easy to solve. Okay, this is quadratic equation, so you can use any method that you have learned to find the root for the quadratic equation. Now how about this function here? Okay, gx equals to x squared plus 3x minus exponent x. Now obviously this is nonlinear because x is x squared, so we know that there will be more than one root. Okay, so to solve this, you cannot use any quadratic equation approach because this is getting a bit complicated. Okay, so in this case, we need to look at other approach. Okay, so to solve nonlinear equation, there are three iterative methods. Okay, the first one is bisection. The second one is secant method. And the third one is Newton-Raphson. So these are called iterative method. So in this topics, we're going to look at all these three methods to solve nonlinear equation. Okay, so what do we want to find? We want to find the root. Find the root of a nonlinear equation. That's our main objective. Okay, so let's recall these three methods here. Okay, this first method that we want to look at is bisection method. Now, bisection method is something like finding the root in a way that depends on the interval given. Okay, so for example, let's say I have this graph here. Okay, let's say these are the graph of a function. I want to call it hx. Okay, so we don't know the equation, but you know the roots are. Okay, there are at least 1, 2, 3 roots when my hx equals to 0. Okay, now how can you locate this root? That's what bisection does. The bisection method will try to locate the roots and approximate to find the nearest root. Okay, so it can only do one step at a time. Now to locate the roots, you need intermediate value theorem. So this theorem, I will call it IVT. This theorem, the only purpose of this theorem is to locate the root. So how it does, so let me just briefly tell you what this theorem do. So let's say if fx equals to 0, in this case I would really like to use hx. Okay, for this case, let's say my hx equals to 0. Okay, this equation equals to 0. And it must be nonlinear. Okay, I'm particularly looking at nonlinear equation. Now if what happened here, if let's say h of a multiply with h of b and is less than 0, then we can say that at least one root exists in the interval AB. Okay, it's very easy. So you need to find the interval. So let's say my interval AB start from, I don't know, maybe here. This is my A. This is my B. Okay. So if I can get any value from A and B, so you can start with, so for example, my A and B is 0, 3. Okay, so this is my A, this is my B. Now remember, 0, 3 is a very big interval. And at least from this graph, we know there are 2 roots. We have 2 roots at least here. So you will not able to find the roots in this large interval. Okay, but we can try to narrow it down. Okay, for example, what we can do here, I can say that, okay, now first start with the interval 0, 1. Okay, so if this is 0, so what here, let's say this is 1, and then we have approximately 2 here and 3 here. Okay, this is just a sketch. This is a sketch of the interval. So if I choose A is 0, B is 1, now I can manage to find the root by using this interval. And then the next interval that I need to try on will be, obviously the next interval lies on the interval 2, 3. There's another root here, there's 1 root here, and 1 root here. So this is how you narrow it down to find the root for bisection method. So the goal is, okay, let me just give you the general idea. So you start with the big interval. Okay, you check whether the root exists or not. If it's not exists, you're gonna narrow it down to a small root like this, and then keep narrowing it down here, keep narrowing it down to here, keep narrowing it down to here until you find the root. This if you choose the interval 0, 1. Now if let's say you choose the interval 2, 3, okay, for instance, so you start with this interval, it will keep locating using the intermediate value theorem. We'll keep locating until it finds the second root. So this is how bisection method works. I'm just giving a brief introduction to it. Okay, we are not looking at solution yet. Now the second method is secant method. Okay, secant method is a bit different. Okay, to understand secant method, you need to use a line need to connect to two value. Okay, let's say this is one equation. I call it maybe gx. For secant method, you start with a line. Okay, you have a line here, it cuts through. Okay, you have two lines here. Start with x0, x1. Okay, so there's an equation involved to find the secant method. So once you it will cut through this line and then plug into the equation. It will solve it again. Cut to this line now, so it will get a new line here. Cuts through another line until it find here. This is the root. So in this secant method, so you need 2 points. Okay, 2 points, whether xk minus 1 and xk. Okay, and you need a line that cut through the curve equation. Okay, now xk are the value where the crosses the x-axis. Okay, such that when this is my y equals to 0 or gx equals to 0. Okay, the secant equation is given by this formula. Okay, so and then don't forget to multiply with the function xk minus 1. So if you look at this equation here, okay, if you look at the secant equation, obviously you need 2 points. Okay, k minus 1 and k minus 2. So in this case, you see that you must start k with 2. Okay, so you're finding x2 using x1 and x0. Okay, so once you find x2, you will find x3, x4, x5 until you found the root. Now, how do you find the root? So, how do you stop in another way? So, you stop when, obviously, when y equals to 0. In other words, when my this equation here, the function here, gx, okay, when gx equals to 0. Now, sometimes it's difficult to get the equation exactly 0. So, in this case, we can set a tolerance. Let's say gc, this is c is an interval or any interval. Let me just put it easier. So, we stop when gx here less than epsilon, where epsilon is a very small number. So in this case, we can say that, let's say 0.0005. Okay, so you keep the iteration going until you get satisfy this condition, and then you stop. Now your root will be whatever the kth value of x. Okay, so this is secant method, and I don't have much time to explain about another method called Newton-Raphson. Now this Newton-Raphson, we can look at the next video that explain about this method. Okay, so I'll see you in my next video. Bye.